Well, hello. It is me, again, giving you some more mathematical knowledge since you're all craving it. I'm here to provide. So, we are doing the second part of 5.2, which in the note sheet is starting on page 8. And we're going to start getting into square roots and simplifying with square roots or cubic roots or all the different radicals. And so there's just some theorems and some things that we are going to use here. Just for some terminology, you can check out what each of these things are. Radicand, radical symbol. This is the cubic root, so the index tells you what type of root you're taking. And then this is just the coefficient. So you would do the cubic root of 7, multiply that by 5, and that would be what this would ultimately become. Okay, so as we work with roots, there are some things that we are going to utilize. And so if you notice, if you have a fraction here, which is just basically division, what you can do is you can just take each of these roots individually. So you can take the nth root of A over the nth root of B. With division, you can split it up and take the root of the numerator and the root of the denominator. Similar, if you have multiplication, you can also split this up. So rather than multiplying it first and then taking the root, what you can do is you can take the roots individually and then multiply those numbers together. So the nth root of x times the nth root of y. This works for multiplication and division. It does not work for addition. So if this was the nth root of x plus y, you cannot separate this out with addition. It does not work. This does not equal each other. So please do not do that. It only works with multiplication and division. Can you separate them out? Okay, so it works for division, it works for multiplication, not for addition, subtraction. So please even just get this thought out of your head completely. So let's do a couple examples of that. If you take a look at example number 1, you have the cubic root of 18 and the cubic root of 12. Well, neither one of these are perfect cube roots. There's no number that when you multiply by itself 3 times you get 18 or even 12. So what we can try to do is work backwards from here. I know that 2 cube roots individually multiplied can just be 1 cube root of 18 times 12. Well, what is 18 times 12? Well, 18 times 12 is 216. And if you refer to the power card that is on Google Classroom or just thinking about perfect cubes, this actually does go in evenly. The cubic root of 216 is 6, because 6 times 6 times 6 is 216. So that would simplify all the way down into 6. You can do that for multiplication. You can also do that for division. So you have the 5th root of 192 over the 5th root of 6. Well, neither one of those are perfect 5th root. So what you can try to do is just take the 5th root of whatever 192 divided by 6 is. Just do it once. And 192, if you do 192 divided by 6, 192 divided by 6 is 32. And then the 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2 gets you 32. Last one, if you're going to write this as a single radical, you have 2 fifth roots multiplied individually, so you can combine them into 1 fifth root. 8 times 6, well, 8 times 6 is 48. A to the first times a to the third is a to the fourth. And you actually can't simplify this any further, so you can just leave it as the 5th root of 48, a to the fourth. It's a little cleaner, a little bit more simplified than these two here. So basically what you're doing is you just apply the operation, whether it's multiplication or division, and reduce all the radical factors that you can.
This is a reminder to all students that socializing is not prohibited during this
Sorry, Miss Paul is making a wonderful announcement right now. Maybe you can hear her. Get your belongings and get out of here. That is the moral of that announcement. So, there you go. There's page 8. Starting to simplify these a little bit. Okay. And if we were in class, we'd probably do this little warm-up up top here so that you can kind of remember what we did earlier. So I will just provide you with these answers. Please make sure that you know why these answers are what they are. Okay. And then these last two, they're started for you. You just kind of have to then finish out their problem. So remember what we did when we simplified radicals. You tried to pull out all the perfect squares from 108. And the perfect square that's hiding in 108 is 36. So 36 times 3 gets you 108. And then from x to the 7th, you're looking at all the perfect squares in x to the 7th. Well, here's a perfect square, here's a perfect square, here's a perfect square, and then you have 1x left over. So if you start simplifying these things, start simplifying your perfect squares. Well, the square root of 36, the square root of 36 is 6. This doesn't have a perfect square, so you're just going to leave it alone. X squared, the square root of x squared is x, but you're going to do that once, twice, 3 times. So this is going to become an x to the 3rd. And then the stuff that is still underneath the radical that can't be simplified anymore is this 3 and that x. So that will simplify into 6x cubed times the square root of 3x. So using similar logic here, we're going to look for perfect cubes. Is there any perfect cubes in 54? There are 27. So since 27 is a perfect cube, you pull that out, and 27 times 2 gets you the 54. All right, how many perfect cubes are in A10? Well, you have A3, 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 A1. And I'm running out of room, but then it would be B3, B3 to get you B to the 6th. So that should all be under the radical sign. I just ran out of room. So then do all your perfect cubes. Cubic root of 27 is 3. Can't do the cubic root of 2. I can do the cube root of each of these, and if I do the cubic root of each of these, I get A. So I get A for this one, A for this one, A for that one. So A is A cubed. Going to leave this one alone because that's not a perfect cube. Come here, both of these are perfect cubes. So cubic root of B cubed would get me B. I do that again, so then I would have B squared. So what's still left needing to be cubic rooted is the 2 and the A, so I will leave that alone. Okay. So just a reminder of what you've done in previous lessons. There's also a good warm-up here that works on FOIL. So remember when you FOIL, what FOIL stands for is first, outside, inside, last. Just reminding you that when you multiply these, there's a first term, there's an outside term, there's an inside term, and there's a last term. So to be very careful about when you multiply those. But what I want you to notice about number 1, number 2, and number 3, I'm going to FOIL all of these, but what would happen? Well, because one of these is a positive and one of these is a negative, what would end up happening is that the middle terms would cancel out, right? So here you would do 9 times 9, you would get 81. You would do 9 times minus x and get a minus 9x. 9 times a positive x is a positive 9x, and then a minus x squared. So because these are the same terms except one's positive and one is negative, the outside and the inside terms are going to cancel out. So you're just left with an 81, which is this thing squared, a minus, and an x squared, which are these two things multiplied together. Okay, so this term gets squared, this term gets squared, connected with a subtraction sign. And what that is, if you remember, that is what we called difference of squares. Difference of squares. When you multiply two things together, or two binomials together, and if A and B are the same, except one is positive and one is negative here, how this would end up being, as we saw in the earlier examples, that middle two terms cancel out. This 9x and this plus 9x canceled out. These middle two terms would cancel. These middle two terms would cancel. So difference of squares, when you see that, you know it's going to simplify into a squared minus b squared. And there's a fancy name for this, and the fancy name for this is conjugate. These two things right here are called conjugates. And basically all that means is they're conjugates because one is a plus b and the other is a minus b. So a plus b and a minus b are conjugates of each other. 9 plus x and 9 minus x are conjugates of each other. 3x minus 6 and 3x plus 6 are conjugates of each other. You have one addition, one subtraction, and so since these middle terms are canceling out, they would be conjugates of each other. And we're going to use that fact to simplify square roots and to what we're going to call rationalize the denominator. We've done some work with rationalizing the denominator before, but I'll show you how the conjugates are also going to take part of that. So remember, for rationalizing the denominator, the goal here is to get the square root out of the denominator. Laws of mathematics say you cannot have a square root in the denominator. So you're trying to get the rats out of the basement. If you remember that Mr. Kuiper quote, got to get the rats out of the basement. So we've done this before when the denominator has just been the square root of something, right? If it's the square root of a, what you would do is you're multiplying by 1. But that 1 is strategic. Right? Anything over itself is equal to 1, so that's why root a over root a is equal to 1. So you're multiplying by 1, which doesn't change the entity of the problem at all, but what's going to happen is if you multiply it by root a over root a, then the radical will get out of the denominator. So we've done this already. This is something that hopefully is not brand new. We've done this one before. But sometimes your denominator is not just going to be a single square root. It's going to be a single square root joined by adding some number as well here. So we're still going to multiply by 1. Okay? But once again, this 1 is going to be strategic. And in this case, you're going to multiply by the conjugate. So if you have a denominator that's a plus the square root of b, the conjugate would be a minus the square root of b. So you're still multiplying by 1. Anything over itself is equal to 1. But in this case, to undo the radical down here, the only way that this radical is going to go away is by multiplying by the conjugate. Because the square root terms are going to cancel each other out, just like these terms here cancel each other out. It's a difference of squares. So those square roots are going to cancel themselves out. Okay. So let's do some examples of this, and then we will be all set. So these are ones that you've done before. So you have 3 over the square root of 2. So to get the rat out of this basement, you're going to multiply top and bottom by the square root of 2. And you multiply straight across. So 3 times the square root of 2 is just 3 root 2. And then the denominator, root 2 times root 2, the square roots kind of cancel out, and you're just left with a single 2. Similarly, in number 2, you need to multiply top and bottom by the square root of 6. And now when you multiply straight across, this is 4 times root 2 times root 6. So what you can do is we learned earlier that the two single square roots multiplied can combine. So this can actually combine into the square root of 12. Root 2 times root 6 is root 12. Root 6 times root 6 is 6. Now, there's still some simplifying that needs to happen here. The square root of 12 is not fully simplified yet. And we learned right away in this lesson how to simplify the square root of 12. You pull out all of its perfect squares. Okay, so remember, the square root of 12 I can rewrite as root 4 times root 3. Because 4 is a perfect square, square root of 4 is 2. So actually, square root of 12 fully simplified is 2 root 3. So when I see the square root of 12 here, I can replace it with 2 root 3. So I need to do that. In order to keep simplifying. 4 times 2 is 8. So this is 8 root 3 all over 6. And if you were just given the fraction 8 over 6 is a fraction that can simplify. Take a 2 out of each of them. Divide both of those by 2, and you end with a 4 root 3 all over 3. So a lot of simplifying that needed to happen for that one, but hopefully multiple steps that you know how to do combined into a problem. Hopefully that makes sense. Okay. So for these U-tries, once again, I'll just give you the answers here so that you can make sure that you know that you're doing things correctly. Number 1, you should simplify that into the square root of 15. And then number 2 should simplify into 4 root 3 over 3. So you can check to make sure that you have those answers correct for numbers 1 and number 2. So now when we come down to these, you can't just multiply top and bottom by the square root of 5, because if you did that, you would have to distribute this square root of 5 to both of these terms in the denominator. Root 5 times 1 is root 5. Root 5 times root 5 just gives you normal 5. That doesn't really help because now you still have this square root in the denominator. So that doesn't work. So that's why we have a different option. If your denominator looks like this, you have to multiply by 1. That 1 will be a strategic 1 formed by the conjugate. So if this is a plus square root of b, you need to multiply top and bottom by a minus the square root of b. So in this case, I need to multiply top and bottom by 1 minus the square root of 5. Okay. So the top part, you're going to do 2 times all of 1 minus square root of 5. That's what your numerator is going to be. We will take care of that in just a second. And then now the denominator, you're multiplying 1 plus root 5 times 1 minus root 5. So normally in these type of situations, you FOIL and you do first, outside, inside, last. Okay. But what's going to happen is, since you're multiplying by the conjugates, the outside terms and the inside terms are going to end up canceling each other out, right? Because when you do a plus b times a minus b, what you end up getting every time is a squared minus b squared. So in this case, you're going to get 1 squared minus root 5 squared. Those middle terms are going to completely cancel out. All right. I'm not going to distribute this yet, and I'll show you why in just a second. I'm going to leave it as 2 times 1 minus root 5 in the numerator. What this becomes, 1 squared, well, 1 squared is 1. Root 5 squared is 5. And 1 minus 5 is negative 4. Okay. And the reason I didn't simplify this right away is because now, ignore this thing in parentheses, you just have 2 over negative 4. And 2/4 simplifies into 1/2. In this case, a negative 1/2. All right, so this just becomes a half, and 1 times all of this is just itself. So 2/4 simplifies into a half, and I would leave my answer like this. Right. So sorry, I got a little carried away. Did not space this out well. I'll have to write smaller for this one. Okay. So let's try this again. You have 5 over 3 minus root 2, so I need to multiply by the conjugate. And the conjugate this time is 3 plus the square root of 2. So multiply top and bottom by 3 plus the square root of 2. I'm going to leave my numerator like this for now. I'm just going to hold off. I'm not going to do the distributive property yet. Okay. The denominator, once again, since you're multiplying by the conjugate, it's going to end up being a squared minus b squared. So in this case, 3 squared minus root 2 squared. I'm going to leave my numerator alone. 3 squared is 9. Square root of 2 squared is 2. And 9 minus 2 is 7. And I'm going to leave my answer just like this. You don't need to actually distribute that 5 through to each term. You can, it's not wrong, but I'm going to leave my answer like this, as 5 times quantity 3 plus root 2 all over 7. Okay, so hopefully you're used to these, multiplying by 1, just whatever this term is down here, multiply top and bottom by that to get the radical out of that denominator. It's a little bit trickier when you have multiple terms. You have to multiply by the conjugate, which we've done. So try these out. Remember here, if this is 2 minus root 5, you'd have to multiply top and bottom by 2 plus root 5. And if you do that successfully, this should simplify all the way down into, so let's bracket this off. For number 1, it should simplify all the way down to negative 3 quantity 2 plus root 5. So see if you can get that. And then number 2, after you multiply top and bottom by 1 minus the square root of 2, it should simplify all the way down into this. Okay. So multiply by the conjugate and then just do the difference of squares, simplify those differences of squares, and hopefully each time you can get the correct response, the correct answer here. Page 11 is just some additional practice for each of these. This is this one's okay. This one's a little bit tricky. All right, so you can challenge yourself a little bit on this one. Multiply top and bottom by 2 minus the square root of 3. Now, in the numerators, when you multiply these, you're going to have to FOIL them. Okay, so that would be a little bit tricky. See if you can do it. Once again, I'll provide the answers to these so you can see if you're doing things correctly. For the first one, you should end up here. And for the second one, after you FOIL the numerator, you can actually just leave it. It should look like this after simplifying radicals. And then your denominator will end up being over 4 minus 3, but 4 minus 3, as we all know, is 1. So really it's just all of this numerator here. Okay. So, a lot there. Just remember, simplify radicals. Either multiply by whatever this is, if it's a single term, or multiply by the conjugate. Difference of squares will be your friend, and hopefully you can practice that and start making some sense. Thanks, y'all.